The bow and arrow have come a long way since the Stone Age. In the 1960s, an American engineer added cams and cables to produce what is now known as the compound bow. Concept-wise, he hit the bullseye. With this new bow, archery entered a whole new era. The compound bow puts greater energy behind the arrow so it flies faster and straighter. This means it's more likely to hit the mark. It starts with this computerized tool. It carves a latticework of holes in the riser, which is the aluminum framework. The holes lighten the bow substantially. Next, a printing cylinder applies an activator to release inked graphics from a starch-based film. The film rolls into a tub of water. The film dissolves and the camouflage-style graphics are now afloat. Machinery dips the bow risers into the floating artwork, and the graphics adhere to them. A camouflage design now covers the entire surface, including all the crevices. After a wash and dry, the risers are sprayed with a clear acrylic coating. In the meantime, a technician prepares 10 bowstrings at once. Each string will be made of 20 synthetic strands. He ties the fibers to the prongs of a wheel, and as it turns, it winds the 20 fibers into one bundle. The result is a bowstring that's so strong, it won't stretch under tension. Next, the string builder wraps one of the bowstrings around the posts of a jig. He winds a thin braided string around a strategic section to reinforce it. This is called serving. He closes the jig to loop the string at the reinforced juncture. This loop will be used to tightly attach the string to the pulley wheel known as the cam. He loops the other end now and spins the synthetic string wrap further to provide extra protection. He stops at the point where the arrow will sit prior to shooting. He pulls the string apart and inserts the end of more serving string. He winds it around this site to bolster the bowstring at this location. He burns off the end to seal it. He ties a loop around the reinforced section. This is known as the shooter's loop. It will be used to nock or hold the arrow. To keep the string from oscillating when drawn and ensure a quiet, steady shot, they install 2 rubber dampeners. A machine pulls both ends of the string through the dampeners to slide them into position. The riser is now finished, so they add the handle, string stop for more dampening, and the arrow rest. It's time to give the compound bow that all-important leverage. He screws a limb and cam to each end of the riser. A device presses the bow to load tension. He slips the end loop around the cam post and winds the string around the cam track. He pulls the string to the other cam and winds it. He then turns the cams to tighten the string. Finally, he runs 2 cables to the cams, completing the mechanics of the compound bow. He splits the bowstring at a predetermined location and inserts an aperture through which the archer can view the target. He now frees the bow from the press and locates the shooter's loop more precisely with a special measuring stick. Satisfied with the placement, he tightens the loop to the string. He winds more synthetic string around the aperture to secure it. He burns the end of the string down to the knot to prevent unraveling. At this factory, they produce 1 compound bow every 3 minutes. With production targets now met, it's time to aim for success at the shooting range.